Good morning, everyone. It's nice to see so many people here early on a Monday morning. Thank you for that. My name is Usha Srinivasan. I'm the director of the Market Intelligence team here at Mars. And it is my pleasure this morning to launch the first Mars Market Insights series, which will be run quarterly to educate entrepreneurs and other stakeholders on specific market and industry dynamics. Today we have a distinguished set of panel members and moderator. It is my pleasure to introduce to you the moderator for this morning, Jon Dogterom, who's our Cleantech advisor here at Mars. Jon has many years of experience in the EV space and was most recently with Hydrogenics as the director of BD. Prior to that, Jon was with Pembina Institute. Please join me in welcoming him to the podium. Jon.
Thanks very much. Yeah, thanks again, everyone, for coming. There's no doubt that we're seeing a resurgence in electric vehicle technology. In 2009, this industry, so electric vehicles, batteries, and fuel cells, saw venture capital investments in excess of $1 billion, putting it right at the top of the clean tech investments. So this sector has been moving along really well. Now you can see there's about 1 million Toyota Priuses on the road worldwide. Lots of other auto manufacturers have introduced battery gasoline vehicles. And what's happened is now there's a supply chain for electric components. The automotive OEMs and new car manufacturers that are starting to be formed are now talking about plug-in hybrids, taking us one step further in electric dominant designs. And with alternative fuels, battery chemistries moving at the pace that they are, there is the possibility of moving to 100% electrification. It's great to see so many Canadian automotive suppliers and energy storage companies starting to get involved in the field, and a lot of those companies are here today. And with the renewed interest, there's a huge opportunity for entrepreneurs in the field and a great opportunity for investors and governments that are supporting them. We have 3 really knowledgeable speakers here today to give their perspective on the market. Just before I get to introductions there's a few people here that I wanted to mention. Part of what we're doing here is giving everyone a chance to meet, and we have some of the leading minds in electric vehicle technology in Ontario here today. We have Al Cormier with Electric Mobility Canada, Martin Rover with Better Place, Juan Tosto with Toyota, Graham Baldwin with Zen Cars, John Broadhead with Metrolinx, and many more. With that, I just want to introduce our first speaker, Sarwant Singh. So Sarwant is a recognized thought leader in electric mobility, and he's been engaged with some of the world's leading organizations, helping them to evaluate and implement growth strategies in the market. He joins us from Frost & Sullivan, where he leads the automotive and transportation practice globally.
Thank you, John. Very good morning. Very good morning to you all, ladies and gentlemen. The theme of my presentation is to start with giving a little bit of the mega trends, talk about some of the mega trends which will impact personal mobility and which will impact the car of the future. I'm going to talk a little bit about the market overview, the roadmap, some forecasts, but the key part of my presentation today is to focus on the business opportunity, not only for the automotive companies, but also for the value chain and everybody in the ecosystem. So let me start. First, one of the big main trends, and this trend will really drive electric mobility, is the urbanization. We see 3 main trends in urbanization. The first one is development of what we call mega cities, cities with more than 10 million population. The second big trend we see is the development of mega regions. What I mean by this is cities, suburbs, and daughter or neighboring cities are coming together and becoming one big mega region. A great example of this is Joburg, Pretoria. If you've been to South Africa, Pretoria is about 60 minutes drive. Joburg, Pretoria, and Gauteng region is becoming one big mega region. And the locals already have a name for it. They call it Jotoria. The other big trend we see in terms of urbanization is the development of mega corridors. A mega corridor is a city or a couple of cities which are over a distance of 100 kilometers. A great example of a mega region is the Hong Kong, Shenzhen, the area around there, which is over 100 kilometers in distance, population of 160 million, heavily, very good infrastructure already in place. This trend, and let me talk a little bit about how urbanization will change and the impact it brings. If I just start from the 50s there, that's a typical downtown, a small downtown with little roads coming in. If I zoom you into 2000 today, we see inner and outer ring roads in all major cities. And if I just take the example of the city I come from, London, the outer ring road is the M25, which is about 25-mile radius. Typically, the outer ring roads are at the radius of 25 miles. And if you look at how the city has expanded, it has expanded all the way to the M25. If I zoom you into 2020, how the city is going to develop, and this is the case of all major cities, the cities are expanding beyond these ring roads to the third and fourth tier belt, which typically today is a rural belt. Let's look at the implications of this expansion to personal mobility, for example. We see a trend in the future whereby the amount of traffic coming in and out of the city during rush hours will be very similar. We already see an example of that in Chicago. We see people living in cities will be people with high income, no kids, and a very services-based economy, whereas people living outside the city will possibly be most likely be with families and drive conventional vehicles. As a result, we see polarization of vehicle sizes, and that's really driven by a number of factors. The two important factors is congestion charging. In Europe, we expect 13 cities to have congestion charging. We expect New York to have congestion charging in the near future. We expect over 150 cities in Europe to have low emission zones. As a result, the type of cars, the type of commercial vehicles in cities will be small. City cars most likely will be hybrid or electric. We also see hub and spoke logistics centers coming in, as you see on this picture, which might mean that access for big trucks to cities will be restricted. As a result of this, we see electric cars, city cars really growing. And we also see a market where new personal mobility models will come in. And let me just talk about one very exciting new personal mobility model, which is car sharing. Today in the US, we have about 26 car sharing clubs. In Europe, we have over 100 car sharing clubs. We expect over 9 million members in Europe and North America together being members of car sharing clubs. We found in our study 40% of people who joined car sharing clubs gave up ownership of cars. Every car that went into a car sharing club took 7 to 9 cars off the road. If you look at the Autolib program, which is coming out in France, 7 programs will be run. The first one is going to be run in Paris. They expect to have 3,000 cars all electric. Now, what is interesting with car sharing is we are finding car companies as well as car rental companies coming into this business. And more we are seeing car companies say they're not in the business of making cars, they're in the business of providing personal mobility. And here's a great example of a company which has been very innovative. Peugeot in France has launched a program called the MU program. What this program is all about is you get a card, it's a loyalty card, you get a number of points on it, and you can use any form of transport. So if you're going on the underground or using a car sharing or a bike sharing, you can use this card. It gives you more loyalty points. And during weekends, you can hire any car. And if you like to drive a Ferrari on the weekend, you can hire it from Peugeot. Well, not really at the moment, but you can technically in future. So what they're doing is they're integrating all forms of their transport. So the two-wheeler business, the four-wheeler business, and they're really using electromobility to bring this new kind of driving experience to the customer. Let me talk a little bit about volumes. It's highly debated. Carlos Goshen says there will be 10% cars. By 2020, we in Frost & Sullivan believe under two different scenarios, it could be anywhere between 7 to 12% of total cars produced globally. This is our Frost & Sullivan scenario, which is more the mid scenario, which suggests about 1.3 million cars fully electric. So these are cars which can be plugged into the mains and charged. We see a little difference between regions. We believe Europe will go in for more battery electric, so 100% electric cars, whereas in the US, we might see range extender and plug-in hybrids being as popular as the full plug-in cars. Now, what is interesting is the number of car companies coming in and the number of models being launched. We expect about 47 OEMs to launch about 75 models by 2015. And again, what's interesting is they will not compete in one or two segments like the Prius, but they will compete across segments. So you can see here on this graph, you have a penetration of electric cars in almost all forms, all segments of vehicles. What is another interesting thing is the Chinese OEMs. We expect 35 EV models to be launched by Chinese OEMs in the next 3 to 5 years. But at the same time, we don't expect China to really be a big market in the next 3 to 4 years. I think it'll pick up mostly around 2015. But China is a threat, and if you look at the technology and the model plans, it could be a threat for the future. Sometimes when we talk about electromobility, we talk too much about cars. I think we need to understand there are other forms of transport which will have much higher volumes. And it's very important if you're looking at a business case for electric mobility to also look at the two-wheeler market. About 25 million two-wheelers which were electric were sold last year. Over 90% of these were push bikes. Over 90% of these were sold in China. But it is expected these numbers will grow globally. It is expected that in China, in cities like Beijing and Shanghai, legislation might push you to say that you can only drive electric two-wheelers below a certain size. And just imagine the impact it will have on the market. Let me talk a little bit about the business model, and that's what we're here for. This is roughly what the chain is of the industry. On the right-hand side, you see the traditional manufacturers, the OEMs. We've seen system and battery manufacturers come in. On the left-hand side, you see the utilities and charging station manufacturers come in. And this is a great business opportunity for them. But what I find, and I feel, is very important, is to have somebody what we have termed as an integrator. A good example of today of an integrator is Better Place. This is the organization which brings the value proposition of electric mobility to the customer, and it combines the whole value package. We believe 3 in 4 electric cars will be sold using a new business model. The cost of the battery today is almost the same as the cost of the car. So how do you package it? When you buy your car today, do you pay for 3 years of fuel? You don't. So the only way the OEMs can really leverage this and make more profits is to go down the route of an integrator. So what really is this integrator? We've clubbed an integrator to maybe offer about 5 services. Charging stations is the first one. They might source charging stations, or they might build their own charging stations, but they will do installation and maintenance of these charging stations. Again, you can have these charging stations at public places, semi-public places, but also you could have these at homes. For every car, we believe in the first year, you can have between 2.5 to 3 times charging stations. So if you have 8 million cars in 2020, we believe by 2020, the ratio will be about 1.5. You can imagine there'll be 20 million charging stations out there. The other market is battery. Now again, with battery, it's very important to look at the whole life cycle of the battery. Battery second life, battery recycling will be very important markets to the future. We believe the battery recycling market will be worth about $3 billion globally by 2020. Of course, it's not going to pick up for the next 3 to 5 years because we're not going to have enough batteries out there in the market, but it's definitely a long-term business. Then you have electromobility. Some integrators like Better Place in Israel will also sell cars. We are seeing a large number of new players interested in this market. Best Buy, which is the big electronic retailer, as you know, in the UK is opening 10 superstores, and they want to sell electric cars in their superstore. And they want to sell them using a very new value proposition, which is the car comes free, but you need to pay 300 euros per month to access the energy package. And if you buy an electric car, we will package with it some combined heat power plants or a solar plant to go with it. In terms of electricity, there's a huge business case for utilities. The business case is not to have batteries, but it's to do load balancing. It's very important for utilities to understand what is a daily driving profile of a customer, what is the charge profile, and what does that mean in terms of load profile. You can balance a large proportion of your load very efficiently using electric vehicles. And of course, then you have telematics and value-added services. So an integrator can offer all of these services or some of these services. And this will be a very important, we believe, in the future, a competitive ground for competing by the companies. Just briefly, we did some work on looking at the business model for utilities. Very interestingly, we found, and these are numbers for Europe, looks at about 250,000 cars in operation, all electric. roughly about 25 kilowatt in power. We found for utilities, the business case is not about selling energy. Especially in the US, it's 8 cents a unit, you don't make money. So the business for utilities, or the return on investment, will come from other value-added services like selling charging stations, maintaining and installing them, things like retailing, advertising, load balancing, garage referrals, data downloads. So if you are a utility, you really need to think out of the box in terms of how do you exploit this opportunity. One of the other interesting trends we see, I'm guessing a lot of you have Apple iPhones. You've seen what application store is done to you. Application store is coming to cars now. Already, if you go on the iPhone, you can see a large number of mobility-based applications. We see a lot of these applications coming into the car, and a lot of these will be integrated as part of your e-mobility function. Already we see shared vehicles, for example, part of it. In terms of electric vehicles, we'll get things like electric vehicle billing, booking, charging station locator, even preconditioning of the car using your Apple iPhone. So again, there's an opportunity for entrepreneurs to launch specific applications for this market. One of the other key interesting opportunity is to develop an IT infrastructure. A lot of the people I have been in touch with believe to have electric vehicles you need smart grids. The answer really is no. You do not need a smart grid. All you need is an efficient command and control center. And I've seen the command and control center of Better Place. I've seen one on Leaf. And really, if you look at how they manage it, by connecting every car, every charging point, every battery, and managing a load profile of a customer, it's pretty efficient. So again, there will be opportunities in the future to work with companies. If you look at the Autolib program, to manage 3,000 electric cars and charging point, that is a substantial investment in IT infrastructure. Looking at some of the technologies within the car, sorry, I apologize for the size of the font here, but you'll have access to these slides. For entrepreneurs, there's opportunities for taking certain technologies which never came in cars, for example, by-wire systems, but also there's opportunities for new technologies in cars like range extender. So we will see with electric mobility a lot of new technologies and evolving technologies coming inside the vehicle. At the same time, there are a number of opportunities outside. A lot of electrical products like charging station, receptacles, power electronics will be used a lot in vehicles, also outside the vehicle. So again, I think the important thing to understand with electric vehicles is the obvious opportunity is not making cars. The opportunity is really in the ecosystem from end to end, looking from the raw materials to recycling. If you look at the whole value chain, there are substantial opportunities for a number of companies and players to enter this market. Thank you.
Thanks very much. Our next speaker is Dave Pascoe. Dave participates in Magna International's electric and hybrid vehicle development and integration programs as a VP for Magna E-Car Systems. He also manages the corporate engineering group at the global headquarters in Aurora for Magna E-Car.
Good morning, and thank you for having me with you here today. I'm going to talk about electric and hybrid vehicle challenges and opportunities. So first, I want to give you a very brief introduction about Magna International. We're the largest auto parts manufacturer in North America, third largest in the world, and most diversified of any auto parts manufacturer in the world. Our core groups shown on this slide each have an average of about 30 manufacturing divisions. And in addition to making components and subsystems for our customers, we also manufacture complete vehicles for them under our brand. Some of you may drive vehicles made by Magna International, but may not realize it. So founded in 1957 in Toronto, Canada, we moved into the United States and Europe quickly, and then more recently into Asia and South America. Today, with over 72,000 employees, we're operating in 25 countries. So on the electric and hybrid vehicle topic, I want to cover 4 areas, including the business case, packaging, components and systems, and then our group and project structure, how we accomplish things in Magna. So like any vehicle program, for electric and hybrid vehicle programs, there are fixed and variable costs. Higher volume is and will be the key to making winning hybrid and electric vehicle programs sustainable. It's the goal of most vehicle programs to sell high volume because you have to pay for your upfront research and development, you have to pay for your capital equipment and tooling and so on. And so without having high volume, it's very, very difficult to do this. With high upfront costs and high variable costs, especially with regard to batteries, this is challenging indeed. Our strategy is to carry electric systems across several vehicle platforms to try and bring up the volume and then bring down the unit cost. Also, one has to respect the buying patterns of consumers, where high-priced vehicles tend to sell in lower volumes. This is US market data from 2008. High fixed and high variable costs tend to drive electric vehicles, range-extended vehicles, and hybrids to a higher price point than conventional vehicles. So if we're to sell vehicles above the average curve, the green curve there, which is the operating area for electric and range-extended vehicles, and we still want to achieve good volumes, we need to have a unique selling proposition for the consumer. So while government incentives may help for a while, ultimately reduced gasoline or diesel consumption versus electricity is the opportunity and the selling proposition that we have to give to consumers. So let's look at today's business case for the consumer. Setting vehicle branding, styling, and other factors aside, what's the payback period for the consumer buying an electric vehicle? The graph shown reflects a payback period which depends on several factors, including on cost for a specified technology, whether it's electric or hybrid or plug-in and so on, price of fuel, price of electricity, and miles driven per year. And the effects, larger battery and higher electricity cost gives you a longer payback period. Higher fuel cost and higher miles driven gives you a shorter payback period. One of the things we learned doing this study is fundamentally that the smaller is the battery, the more vehicles we'll be able to sell for a given platform. So what's the tipping point for the consumer? We would all like for there to be a high volume alternative to petroleum-powered vehicles, and I can say when electric vehicles have similar range, performance, and cost to an internal combustion engine product, I will definitely use them. If we can achieve this, then there will be a tipping point where we can get to the mainstream consumer, and people will switch in high volume to hybrids, electric vehicles, and these cars can take a much more significant share of the market. So on the graph you can see, if we look here on this green curve, the bottom of the green curve is a 3-year payback and top's a 6-year payback. So if you look at a 3-year payback, you basically have to have nearly $5 per US gallon for any of the vehicles to give you a proper payback. And at 6 years, there's a number at today's prices. For example, a hybrid electric vehicle can pay back in a 6-year time period. On the packaging side, so each type of vehicle has a unique set of challenges. In a vehicle conversion, that is starting with an existing platform, that is a carryover internal combustion engine platform. We have to take advantage of space that is vacated by the powertrain and by the fuel cell or the fuel tank. With a purpose-designed vehicle, that is a ground-up blank sheet of paper designed vehicle, we have much more packaging freedom, but we have a much higher upfront cost. Today, most or all electric vehicle programs are low volume, and so that's a very challenging business case to make indeed. And typically, vehicles that are being done by us and by our customers are coming off of existing IC-powered vehicles. So here we have the typical major systems for an electric vehicle in a possible package configuration, and Magna E-Car Systems is capable of the integration of all of these systems so that they work with each other, and we make most of the content already. We're in production on some of these types of systems. We also have production awards which are slated for the next year or two to launch with some of these systems as well. So this is the packaging architecture for an electric vehicle. In addition to physical packaging, making the subsystems work together is another challenge. So you can see, looking on the top right, we have the plug-in AC from grid, which comes from your 120 or 220 port, going into the AC charger, and then the large block in the middle, the orange section is the high voltage section. The large block in the middle is really the heart of the electric car, 400 volt battery pack with cells, and that powers, just to the left of it, the 3 orange boxes, the high powered components on the vehicle. So the inverter motor controller drives through to the traction motor, and the gearbox driving the vehicle that pulls the vehicle along. That's obviously a high powered part. And below that are the heating, ventilating, and air conditioning functions, which also draw significant power. On the right side of the battery pack, you see the DC to DC converter, which takes energy down to a conventional 12-volt lead-acid battery, which powers low power components like the electric vacuum pump, electric water pump, vehicle control unit, and electric power steering, headlights, interior lights, and some of the smaller accessories. It is exciting from an engineering point of view to see some of the new developed products, which historically were always on cars, like water pumps, which have to be electrified now and are being redesigned to suit electric and hybrid vehicles. So on the components and systems side, we want to, as a group, we want to provide a full array of major required subsystems for electric and range extended vehicles and hybrids. And we want to provide complete integration of these systems and subsystems for our customers. So we want to be a one-stop shop for our customer. It gives us a competitive advantage at Magna. And being large, we're able to do that. We want to solve the cost volume issue by providing common components across multiple platforms and multiple customers so that everybody gets the same part, hopefully, and we bring the volume up and we're able to deal with the cost issue, because it is a very big issue for us and our customers. On the product portfolio side, we've been working on electric and hybrid vehicle products for probably over 10 years. We've done prototypes as much as over 20 years ago. I worked on electric vehicles back then, so this is my second time around at it. Examples we have in our portfolio: onboard chargers, generators, chassis traction motors, battery management systems, lithium-ion battery packs, modular powertrain cradles, electric oil pumps, and so on. And then I've spoken about the battery being the big challenge. It is from a cost perspective. The battery doesn't cost almost as much as the car. At the OEM level, it costs more than the rest of the car for an electric vehicle battery with decent range. So it makes challenges for us. What we've done is we've tried to divide the battery into different types to keep as few architectures as possible, and again to try and keep the volume up. So we did an analysis on the power and energy use of different types of lithium battery vehicles. So if you look in the bottom left box, with mild hybrids, full hybrids, heavy duty truck and bus, plug-in hybrids, and electric vehicles, we basically bundled these. And you can see in the graph here where we have energy on the vertical axis, power on the horizontal axis, we've bundled them such that we're able to offer 3 basic architectures to meet the needs of these types of vehicles. Each architecture uses a different chemistry and a different cell form, and also a different cooling system to meet these needs. At the bottom, you'll see some of our history. We did our first generation lithium-ion battery pack in 2006. We went into production in 2009 with lithium-ion battery packs. And then we've got another award as well on the way that's not announced yet, so I can't give any details at this time on that. So cells as well, lithium-ion and others, lead-acid and nickel metal hydride, they have an interesting behavior. I liken them a little bit to be like people. So if you want the lithium-ion battery pack to work well, it's like having a bunch of people trying to row a boat. And if some of them are lazy and some of them are strong, the boat goes in circles. And so operating a lithium-ion battery pack with the battery management system is a little bit like that. And so we have to understand all of the stressors on the cells, what it does to their behavior, because we want them to behave the same. So we do testing on C rate, which is the energy usage rate, temperature range, state of charge, which is from discharge to full charge, up and down, peak power, relationship of charge to discharge current, state of charge set point. If you have the state of charge too high, you have side reactions, which reduces the life of the battery. Duty cycle, use versus rest time, temperature gradient through the cell has an impact, and micro state of charge, which is fundamentally launching, accelerating, and regen braking, which can be in the millions of cycles. So our group and project structure to operate this, we want to find a way to use our electric vehicle portfolio to provide these systems to our customers, and we want to coordinate work between our operating groups. So again, this is the Magna operating groups. Historically, they're fairly independent, so we have to have a way to be able to get everybody to work together and march in cadence to the programs that we have awarded. And so we developed a new group called Magna E-Car Systems, which is responsible for the integration of vehicles, systems, and subsystems using components and systems from the Magna groups and from other suppliers. And this is a different representation of that. So we have inside of our portfolio, manufacturing portfolio, batteries and cells, we do the integration, we pull from Magna and outside companies. And just before I finish, I just wanted to mention as well, we do in Magna also have an electric bike drive operating group. We do make the best electric drive system for bicycles in the world with lithium-ion battery packs. We did 50,000 units last year. 80,000 is, I think, projected for this year, so it's quite a growing and interesting business for us. As well, it's really fun. If anybody's interested to get connected with electric bikes, you can come and talk to me afterward. Okay, thank you very much.
Thanks a lot, Dave. Our third speaker is Joe Cargnelli. Joe is the founder and Chief Technology Officer of Hydrogenics Corporation, one of Ontario's successful startups to emerge on the global electric vehicle market. Joe has been the recipient of numerous awards for the innovations that have taken place at Hydrogenics. The company is now the world's largest provider of on-site hydrogen via electrolysis, and also a leader in the industry in providing proton exchange membrane complete fuel cell systems. Join me in welcoming Joe.
Good morning, everyone, and thanks for the intro, John. I'll be able to skip the Hydrogenics introduction slide. Today I'm going to be giving you a general overview on fuel cell technology. I'll be talking a little bit on where it was, where it is, and where it's going. I will also be talking about the German hydrogen plan. It'll be very interesting to see what Germany is doing with hydrogen and hydrogen fuel cells, as Germany was one of the leading countries to really take off with solar and wind. And finally, I'll be giving you an overview specific to Germany on the relationship between hydrogen and renewable energy. And we'll see how the renewable energy issue in Germany, hydrogen as an energy carrier, and fuel cell electric vehicles really tie in and why they will be successful in Germany. As John already introduced Hydrogenics, I'll skip this slide and get right into the challenges that have been faced by fuel cell electric vehicles. So on the technology side, we've had numerous challenges. They're summarized by power density, so that's how big is a fuel cell. So 10 years ago, a 50 kilowatt fuel cell probably would have been the size of half of this table. Today, a 50 kilowatt automotive fuel cell is about the size of a microwave. So that refers to power density. So how much power are you able to get out of the fuel cell? So today we're at a practical point where a fuel cell can be practically integrated into a vehicle. Durability was another major issue for fuel cell electric vehicles. Again, speaking 10 years ago, the life of a fuel cell, meaning the hours that it would be able to operate in a car, was probably in the order of 50 to 100 hours. Over the years, material scientists have worked on the issues, and today I can say that durability for fuel cells is in the range of 5,000 to 10,000 hours. So we're at a practical point now where fuel cells can be introduced into electric vehicles. The second issue was hydrogen storage. So you need to get a certain amount of energy on an electric vehicle in order for that vehicle to have a practical range. 10 years ago, the storage pressure for hydrogen electric vehicles was about 350 bar, or 5,000 psi gauge. Today, that technology has moved to 700 bar, or 10,000 psi gauge in hydrogen electric vehicles, and we'll see the impact that has on the range of the vehicle. I've talked about packaging, how that was an issue, and the cooling system was an issue. Fuel cells operated at fairly low operating temperatures, and that would require you to have very large radiators on a fuel cell electric vehicle. So now we're on to costs, and certainly we have the infrastructure costs, and I'll talk a little bit about infrastructure and how the costs will come down later in my presentation. We had hydrogen costs, and that was basically the cost of hydrogen. So how much does a kilogram of hydrogen cost either to make or to be delivered to a fueling station? We also have the fuel cell cost, and that is directly linked to volume. So today, there's probably 2,000 fuel cell electric vehicles on the road. At that volume, you can imagine how hard it is to drive the cost down. But as we have high volume initiatives introduced, that'll drive the cost of a fuel cell down. We have system costs and hydrogen storage costs associated as well. The hydrogen storage costs are on the vehicle side as well as on the infrastructure or fueling station side. On the infrastructure side, the challenges faced were reliability. You can imagine as you're introducing your first hydrogen fueling stations, you have some issues to work out. Today we have numerous hydrogen fueling stations deployed throughout the world operating reliably. Availability and focus network are sort of tied together. You need to have a certain amount of infrastructure deployed, or you end up with that sort of chicken and egg scenario where the automobile manufacturers won't be introducing fuel cell electric vehicles in any large number because the infrastructure is not there. The infrastructure companies aren't going to introduce the infrastructure because the vehicles aren't there. So that sort of seems to be the issue that we're in the fuel cell electric vehicle industry. Just about every major automobile manufacturer today has a fuel cell program. Some have been working in the field for over 20 years, others are just getting into the field. We're seeing numerous platforms being deployed in specific areas and geographies of the world. This is the Honda FCX Clarity vehicle. It was introduced in 2007 by Honda. Now, understand for this vehicle to be introduced in 2007, it was probably 2005, 2004 fuel cell technology. And probably the most, or the two most interesting points to me on the spec that we have here for the vehicle are the curb mass and the range. So 620 kilometer range. This does use 700 bar hydrogen tanks. And you can see that we have what I would call a relevant electric vehicle here, a vehicle that is the same size as your family sedan that has what I would call relevant autonomy or range. Just a brief note on buses. There are numerous bus deployments in Europe in various cities. You can see some of the major bus manufacturers that are actually deploying fuel cell buses: Mercedes, Van Hool, Technobus, and Rampini. The bottom two buses that you see in the slide are manufactured and assembled using Hydrogenics fuel cell technology. So why are fuel cells relevant? And I'll be getting into why Germany is pushing hard with hydrogen and fuel cell electric vehicles. To me, this slide sort of illustrates why fuel cell vehicles are relevant. So on the left of the slide here is a gasoline hybrid vehicle, a 2009 Toyota Highlander. You fill the tank up, you get 710 kilometers in terms of range with an average fuel economy of about 9 liters per 100 kilometers. The cost to fill up at 95 cents per liter, approximately $64. On the right is Toyota's 2009 fuel cell Highlander vehicle. You fill the tanks up with hydrogen, you get 690 kilometers of range. It's an average fuel economy when converted to gasoline equivalent of 3.4 liters per 100 kilometers. The cost to fill up with $8 per kilogram of hydrogen is approximately $51. And I can tell you that you can order and have hydrogen delivered today at $8 per kilogram. So this is why, as I get into my presentation and you see why Germany is pushing ahead, there's great interest in Germany. Before I get into this slide, I'll tell a little story here. Many of you probably aren't aware that in, I think it was May of 2009, the Secretary of Energy of the United States, Dr. Stephen Chu, went on record by saying that fuel cell electric vehicles will never come to market, that essentially they need four miracles for the fuel cell electric vehicles to come to market. So that was May 2009. In September of 2009, the automobile manufacturers that you see on this slide basically got together along with the German government and basically signed a memorandum of understanding saying that they're going to pick 2015 as the date that they're going to have large-scale deployments of fuel cell electric vehicles. And what they did is they picked they picked a specific geography to focus on. Currently today, fuel cell electric vehicles are deployed in various cities throughout the world. And if you think of that chicken and egg scenario on how do you focus the infrastructure, it makes it very difficult to focus the infrastructure. So in September, these automobile manufacturers signed up to a major release in Germany of fuel cell electric vehicles. At the same time of that announcement, several infrastructure companies also made a memorandum of understanding, and they signed up to an infrastructure build-up plan in Germany. And what we're seeing here is the German High Roadmap Plan of 2013, 2015, and 2017, and you can see the Tankstellen is the German name for fueling station. And you can see that they're going to be adding roughly 10 fueling stations in 2010, 142 to 218 in 2015, and over 1,000 fueling stations in 2020. And you can see where they're peppering the fueling stations located around the major cities in Germany. In May of 2009, Hydrogenics was awarded one of those fueling stations as they're rolling out. This is a Vattenfall fueling station, Vattenfall being third largest utility in Europe. This fueling station is a 1 megawatt electrolysis fueling station situated in the heart of Hamburg, and it will be used as one of the fueling stations that will fuel the deployment of fuel cell electric vehicles as well as buses. Okay, now on to what's the relationship between hydrogen and renewables, and why is Germany so bullish on hydrogen? And to do that, we're going to look at a case study. We're going to look at a time slot in 2008 to better understand what's going on in Germany. As we get into these slides, I'm sure everyone here is aware of the, call it the issue with renewable energy, that intermittency, not knowing exactly when the wind will blow or whether you will have that energy, and certainly not being able to call upon renewable energy like you can with conventional generating capacity. So Germany is divided up into a few regions in terms of utility control. In 2008, there were over 20,000 wind turbines deployed in Germany with a total nameplate capacity of about 23,000 megawatts. So that was 2008. German plans are calling for doubling that wind install base in Germany, so it's expected to go to 50,000 megawatts by 2020, which is pretty impressive. In 2007, there were 40 terawatt hours of electricity produced, and that by wind energy, and it equaled roughly 7% of Germany's annual electricity consumption. The area that we're going to look at is the E.ON control area, where 40% of Germany's installed wind base is located. So this is a 2-week period in the E.ON control area that we saw on the map, and you can see the wide fluctuations of wind energy that come on the German grid. This is fairly typical, and you can imagine what this will look like when they move to 50,000 megawatts of nameplate capacity in Germany. So this is a major problem for utilities. How do they manage the large spikes in wind, and then how do they manage when the wind drops off suddenly? So everyone's talking about energy storage. Energy storage will be the way that we handle bringing on more renewable energy and handling the fluctuations. So here we're looking at one form of energy storage, which is the pumped hydro. So to give you an idea, the little box that you see there is the amount of energy that would be stored by this pumped hydro facility. And the area under the wind curve is really the energy that you would need to store to help solve the problem. So you can see you're going to need a lot of pumped hydro storage facilities in order to solve the problem today in one region of Germany. And that area, that little square that you see there, is roughly the amount of energy that would be required to refuel 1 million Chevy electric vehicles. So the Chevy Volt, you would need 1,000 of those vehicles to be able to soak up, 1 million of those vehicles, sorry, to soak up that amount of energy. So now I'll go to another form of energy storage that we're hearing a lot about, and that's called compressed air energy storage. So the image on the right is a salt cavern, and today we use salt caverns to store natural gas, and the thought is we'll have lots of salt caverns and we will store renewable energy in salt caverns. So this is a fairly large salt cavern. You can see it's not very efficient. You can see you're storing roughly 4,000 megawatt hours of energy. Again, really not solving the problem in one area of Germany. Now, when you take that same salt cavern and rather than filling it with compressed air, you fill it with hydrogen, you can start seeing now that hydrogen starts matching up to the size of the problem. So the square now is huge. You're really able to soak up all that energy, and that's one salt cavern. And that one salt cavern would be able to store enough hydrogen to fill 3.6 million fuel cell electric vehicles. So you start seeing why Germany is so bullish on hydrogen and driving hard on fuel cell electric vehicles. The utilities have a problem. The problem is fairly large, and you can see the impact that hydrogen has in terms of an energy storage solution. Just circling back to this slide, when you start looking at all these hydrogen fueling stations, and you can imagine that at least half of them will be electrolysis. Every electrolysis fueling station inherently has hydrogen storage in order to fill the vehicles. You can see that the hydrogen fueling stations will be the salt cavern. You basically have distributed fueling stations. Utilities will be able to call upon those fueling stations to shift renewable energy into hydrogen, into storage. So in summary, why hydrogen and fuel cell electric vehicles in Germany? I talked briefly about fuel cell electric vehicles and how they have predictable performance and they have long driving range, which makes them relevant. You can get a family-sized sedan capable of being a primary vehicle. It is zero-emission mobility, and of course you get the fast refueling with hydrogen fuel cell vehicles. But probably the most important thing to leave you with is the future of hydrogen as an energy storage medium and how hydrogen really fits with storage problems, certainly in Germany. With that, I'll leave you. Thank you.
Thanks very much. Thanks to all our speakers. We want to open the floor up to questions, and there are microphones situated at the front if people just want to step forward. In the meantime, I want to ask a couple questions as well. It's great to see the example of what's going on in Germany and how utilities are getting engaged. There's no doubt that electric vehicles are going to really change the relationship and dynamics between energy distribution and transportation fueling. One question that I have is in other regions, maybe where renewables aren't so much a situation for utilities, how do we go about getting power companies to cooperate and getting them more engaged in the introduction of electric vehicles? Anyone wants to share?
I think this is a major challenge, especially in North America. In US, I guess there are about 3,000 utilities. And if you want to bring in electromobility, it's absolutely important that utilities cooperate with each other. Number of challenges. We need specifications. We cannot have 3-4 different types of specifications just for charging the vehicle, for example. Also, the customer has to be able to drive the vehicle across different cities, across different states. So there has to be some sort of mechanism whereby utilities can cooperate. In certain countries, especially like in Germany, in the UK, in France, we're seeing a lot more cooperation, I would say, than we have in the US. So I think one of the sessions I have is absolutely important utilities cooperate. And maybe the best way of doing this is to have some sort of government mandate. I mean, a great example is the country I come from in the UK, where the government's taken a number of initiatives, set up departments, bodies which are supporting the implementation of electromobility across infrastructure with subsidies, plus also setting up working groups to cooperate and bring this to market.
Thanks, Sarwant. Dave, you mentioned in your presentation that you've kind of been involved with electric vehicles in the past, and I think everyone here would agree we've sort of seen this surge in enthusiasm and momentum for electric vehicles before, and then it sort of trickles off after a couple years. What I'm wondering is there anything different this time? Why has that happened in the past? And can we expect the momentum to actually continue this time around?
Okay, that's a good question. Yeah, I did work on electric vehicles back in around 1990, and then I had worked on several other things within Magna since then, but I'm back onto electric vehicles now. The enthusiasm wanes for three reasons, right? One is cost, life of the battery, life of the vehicle, and range. So range is a significant adjustment to people when they realize they can't drive somewhere far on the weekend or so on. So it's limiting in the use of the vehicle. So certainly life has gotten better, cycle life with lithium-ion batteries, range has gotten better, cost has not really gotten better. Lithium-ion batteries are more expensive than lead acid, call it an upfront investment. On a per charge basis, they're less expensive because they have more charges. But the challenge there is having a system or an offering to the public that says, I need you to pay more for your vehicle as a piece of capital equipment, and wait over time for a payback. What we'll see going forward is probably a large growth in mild hybrid vehicles, where you have, and micro hybrid, where you have simply stop-start with almost no enhancement to the battery. Mild hybrid, where you may have a small battery, which drives maybe 500 watt-hours to 1 kilowatt-hour, as opposed to 20 to 30, which you see in electric vehicles. Because the cost for the consumers, the on-cost is much smaller, and there is a payback to that. So the cost-benefit analysis is pretty reasonable there today. And if you look at what's in the car company's product portfolio, what's coming out, that's very prominent in what's going to come out over the next 5 to 10 years. Electric vehicles are a good, noble goal, and as an industry, we're working on them. The main thing driving electric vehicles in our industry right now is legislation. And so if you look to California and some of the other states that may take on the same legislation, in California, you cannot, as a large volume manufacturer, you cannot sell cars without selling zero-emission vehicles. So the lowest cost solution for the car companies is to go to electric vehicles. And of course, this gives us a bit of an opportunity, because there's legislation there, to see what we can do as an industry and to try and work together to get costs down to the point where it can go big. At today's prices, it won't, but costs are coming down, and so there is hope for the future.
Thanks, Dave. Any questions from the audience?
My name is John Banka, and I'm the founding president of the Sustainable Urban Development Association. And this question is addressed to whoever is brave enough to take it on. I see the development of the technology in Europe as being far, far ahead of us here. And I think the main reason is that we are very afraid of taxing gasoline more. It would be the end of society as we know it, I think, is what most people would think. And yet I see that as possibly being a way of making electric vehicles much more cost competitive. I wanted to know what comments of any of the speakers would be on that.
Go ahead.
Yeah. So in Europe, you see there's acceptance of technology in vehicles, and so in our business we have basically, and have had for many years, a list of technologies that are available to us at a certain cost. And so as car companies and the suppliers, we dip into those technologies. As the cost of fuel comes up, we dip in more aggressively into those technologies, which drives up the price of the vehicle and takes down your usage of fuel. But the main driver for European acceptance of these new technologies is the price of fuel there is significantly more than it is here. which was, I think, the point that you made. And certainly taxing gas here, there's a resistance because it affects lifestyle and people like certain types of vehicles. But, that I guess is a policy discussion, whether something's done there or not. Did I answer your question? Yeah, okay.
Yes, I'm Al Cormier of Electric Mobility Canada. Congratulations on the excellent workshop. Could the panel comment on the availability of lithium and rare earths for electric motors? Is there enough, or are we going to have a supply situation in the future?
Thanks. Okay. Lithium mines. There's an awful lot of lithium in the world. In Canada, North America, a lot of places, there's lithium in rock. Sputamine, it's not really the best source for batteries because it contains other elements and it's a bit difficult to extract. Useful in the manufacture of glass. There's salt beds down in South America, which is the main economic source of fairly pure lithium, which is useful in batteries. We've identified sources. I don't know if you guys are aware, Magna has a small investment in one of the lithium mines in South America to secure our supply going forward. But if you want talking to the Lithium Miners Association, their anticipation is, even given the future bringing up of batteries and electric cars, that there's going to be a oversupply, overavailability of lithium for the foreseeable future. And so we don't see any risk there for the lithium itself. There are other elements in battery cells that, cobalt, for example, that are fairly expensive and we may see price fluctuations. But for lithium, some of the richer mines could supply easily across a few mines, supply the automotive industry for the reasonable foreseeable future. So I don't think there's an issue there.
Hi, my name is Bob Pascoe from the Ontario Centre of Excellence, and I just want to raise an issue which I'm curious to see how the panel reacts to this, which is we're looking at tipping points, as you mentioned, David, for making cars cost competitive, capital and operating cost. But then there are certain advantages, maybe it's hard to cost them out, that favor electrification. And I'm thinking things like you get to charge your car at home. So you fuel at home. That's a big plus for a lot of people. You get to choose your supplier. You could buy from various generators, buy a packaged plan, or you could make your own with solar panels or wind. And finally, there's the issue of decarbonization. And the fact here in Ontario at night, we pretty much have emission-free electricity. And so that's a big plus in terms both from legislation but also personal choice. Some people will favor that and be willing to pay extra. So I'm just saying, how would those factors come in, do you think, in terms of helping to tip over into large-scale adoption?
Great question.
So, with regard to some of the soft benefits, I mean, that's up to the consumer because ultimately they'll be given a proposition by the car companies that says, here's the price for the vehicle, do you want to pay it? And so if they see those benefits, then they'll go ahead and pay for that. With regard to decarbonization, as I said, there's a lot of technologies that we can use to bring down the carbon usage of vehicles. So the question would be, for example, should I spend an extra $15,000 to make my one electric car electric? Or if I spread that $15,000 across 1,000 cars and put $15 into each, would I save more fuel? And today, generally the answer is, if I go to the less expensive technology and get a few % off of each car, I'll save more fuel that way. So that's one of the counter-arguments to electric vehicles at this point in time. Not to say that we shouldn't move in that direction. It's as I said, it's a noble goal, and we ought to be working in that direction. We've got to get the cost down to make it all work.
Thanks. If I can just maybe add to that. In my experience, there's a different business case for the customer and there's a different business case for the governments. A case in point, if I take, is the case of Denmark. 95% of Denmark's energy comes from wind power, absolutely renewable. they actually have more power than they need, and they export it to neighboring countries like Germany. For them, the business case is to sell that power in their own country with electromobility at a premium price. Plus, it provides benefits like load profiling. So if you look at some of the early adopter countries in the world, you need to really carefully look at the energy portfolio. Look at Portugal, look at the UK. In UK's case, it's quite the opposite. They don't have very good renewable energy sources, very coal power driven. So you're absolutely right. Looking at the energy portfolio, some of the country's drivers can lead to development of effective legislation, which can help push electromobility. Thanks.
Norm Ledlick from Borden Ladner Gervais. Walking over this morning, I noticed a bit of a nip in the air, which, for all Canadians is a bit foreboding because we know our winter is coming. Was wondering if there were any particular challenges that Canada's cold winter presents either for battery technology or for the fuel cell to recharge the batteries.
Thanks. Joe, do you want
to? So maybe just briefly on the fuel cell. The fuel cell is an electrochemical device very similar to a battery. It also produces water as a byproduct, which would sort of make you think, is it well suited for winters and a cold environment? 10 years ago, cold starts and operating in cold weather was an issue for fuel cells, not from a basic electrochemistry or materials point of view, simply from the fact that if you're producing water inside a fuel cell, and the fuel cell is made up of numerous plates assembled together, if you designed your fuel cell such that water got trapped inside your fuel cell and then it froze and that water, when freezing, would expand, there was the possibility that you would damage your stack. Today, I would say most fuel cell designs, most automotive fuel cell designs certainly are rated for freezing, meaning the fuel cell is able to shut down and freeze, and then it's able to start up. So for fuel cells, it's really not an issue, certainly down to minus 40.
Yeah. Did I lose sound? There we are. Okay. With electric vehicles and lithium-ion batteries, actually most batteries, there's a reduction of ion transport at colder temperature, and so that does need to be managed. The way we deal with that is sometimes you can have a battery pack heater in the car while it's being charged. Other things you can do is you can put call it computer limit on the performance of the vehicle when it's cold until you've used it a little bit, and then it warms up with use, and then you can release the limit so the vehicle goes back to its normal peak power and performance.
Thanks. No questions? One question that I have to all of the panel members, it's always difficult to introduce a new product, and when you're trying to introduce a new product into an industry that is developing, it's even more difficult. We have a lot of entrepreneurs here, and I'm wondering what advice you would provide to someone that has something innovative, maybe on the chemistry or battery side or within power electronics. How do they go about getting into this industry? Where do you try to start with it?
Maybe I can start. I think the number of ways, and I think with electric vehicles, what I've seen is last year we saw private equity companies not funding because of the recession. And we certainly saw organizations themselves, and we worked with a number of organizations, and you've seen how battery companies are buying car companies or startup car companies and vice versa. So one of the recommendations I have is, of course, private equity companies are the first source, an easy source of funding. But at the same time, we are seeing a lot of organizations globally funding electromobility. Secondly, we've seen with car companies especially, they have set up venture capitalist organizations. I mean, you must have heard of GM has one. I know Audi has a venture capitalist firm. So we are seeing a lot of car companies itself, either through their venture capitalism firm, or if they are seeing an innovative technology, doing development contracts. Need to be sometimes a little bit careful because you lose a lot of control if you do that. At the same time, we've seen governments globally. I mean, the US government, with this $25 billion funding, of course, it's a bit challenging if you're a startup, but there are a number of fundings. In the UK, I give the example of Technology Strategy Board, And if you might have heard Gordon Murray, who's got a new, very innovative megacity car design, which will be electric, has got funding of £3 million from the UK government to develop that. So what we're seeing is globally, through various channels, governments, car companies, plus also major manufacturers and suppliers, we are seeing that you can actually approach a number of organizations to get your idea off the ground. And that is something very special with electric vehicle that I've seen.
So the practicality of doing this, what I would suggest is first you make sure your intellectual property is well in order, because if you have a great new technology, people will want to get their hands on it one way or the other. I think on the selling side, you can go directly to the OEMs, which is, you know, Ford, GM, and Chrysler here in North America, or one of the Europe or Asia ones, to get at least their input and their interest, because they will give you feedback. They will take the time to look at your product if it's new, interesting, and useful for them. And then finally to hook up with an existing supplier, because if you're doing a startup, I think to set up that kind of supply base is a pretty big thing. You could go for funding, but I think going with an existing supplier can make a lot of sense as well. And ultimately, if you've been to the OEM first, your product and your idea will be much more interesting to the supplier if the OEM customer, in our business, our customer, is saying, I like that product, I want that product. That makes it much more interesting for us, because I have then somebody to sell it to. Okay.
Maybe just add, I'd maybe take a slightly different approach. I find OEMs typically can be extremely slow with moving with ideas. Maybe another approach could be to approach the sea of system integrators that are out there that are involved with vehicle integrations of one type or another, thereby allowing you to sort of cut your teeth and refine your idea or your product. So the system integrator approach might be faster, quicker to market, where you can get the learning cycle happening a lot faster.
Great, thanks. Another question, it was alluded to a couple times in the presentations, the cost issue that new technologies face, both batteries and with fuel cells. So I'm wondering what sort of volume is it going to take to get down to a reasonable price point? Maybe what is a reasonable price point? And are there other key advancements on the technology side that we think are going to make a lot of headway on the capital cost?
I'd be interested in hearing from my colleague on the cost per kilowatt of hydrogen fuel cells after I make my comment. But one of the just for me, it's useful information, right, for looking forward. One of the things, that's one of the main things, right, is the cost per installed kilowatt. And most things that we've looked at on stationary, we've looked in Magna, we look mainly inside automotive, that's our focus, but we keep an eye on what's going on in stationary power and so on. Micro and small installations, typically $1 to $7 per kilowatt of power installed. The thing that keeps us buying, all of us, you, me, and everybody else, buying internal combustion engine powered cars, 1 kilowatt of power there is 1 to 2 cents, right? So if somebody says you're going to drive your car with this new technology that costs $1 a kilowatt hour, then you're looking at could be a $500,000 motor or something like that, right? So you have to, fundamentally, you have to be economic to be able to operate in the high volume area. So on the volume side, you had mentioned what was a good volume, what would get us there. I think a couple things have to happen, right? Volume helps, but we have to, there still is a need for new technology in the battery area in order to bring the cost down. I think the rest of the electric and hybrid vehicles, the costs are fairly reasonable, fairly manageable, and if we move them down incrementally, we'll get there. And then once we do that, once we have a new battery technology that gets the cost down, I think then everything can go forward from there.
So maybe, John, to address your question on what the volume should be, It needs to be a lot more than what it is today, that's for sure. When you look at the German announcement, it was 100,000 vehicles, more than 100,000 vehicles combined by, or put together by about 6 or 7 automobile manufacturers. In terms of bringing the price down, it's a bet by the automobile company. If you look at what Toyota did with the Prius, they started manufacturing Priuses at a loss in order to build up the volume. The hydrogen and fuel cell industry will require a more organized deployment. So you saw in Germany they're deploying the fuel cell vehicles, but at the same time they're organizing and deploying the infrastructure. That's key, or it won't take off. When you get up to those volumes for a fuel cell vehicle, fuel cell technology of 100,000 type vehicles, that will drive the supply chain. So today we have all the suppliers for all the various subsystems exist. And they're innovating, iterating, and deploying, but it's in very low volume. So it will literally take a deployment of 100,000 vehicles where each automotive manufacturer that steps up to the plate and deploys 15,000 vehicles in year one will be able to start rolling the supply chain and getting that cycle going. Maybe just in terms of cost comparison, where the fuel cell industry is at. Fuel cells are, again, I said very similar to batteries in that they're electrochemical, but they're different in that they separate the power and energy. So we're able to add more fuel, if you will, to the vehicle without doubling the size of the fuel cell as you would in a battery electric vehicle, where if you want to double your range, you'll have to more than double your energy, therefore you'll have to double your fuel cell, or double your battery. So fuel cells don't suffer from that. The power and energy is separate. And fuel cell technology today, after maybe 20 years of focus, has gotten to the point where a lot of the processes are what they call reel-to-reel. So for membrane manufacturing, the high-volume manufacturing has been developed. On the key structural component inside the stack, the bipolar plate, it used to be machined graphite, then it went to molded graphite, and now it's gone to stamped metal. So the fuel cell industry has iterated and moved towards high-volume manufacturing techniques, and it's really at the point now where it needs a high-volume deployment. And when it does that, the promise is that the cost of fuel cells will literally drop down to $50 to $100 a kilowatt. And to really believe that, to understand how low the cost could be, you'd need to look at a fuel cell and see what the basic parts are, and then convince yourself that if we can make an internal combustion engine for $2,000 with all the pieces and the tolerances that are on an internal combustion engine, can we make a fuel cell for that price? I'm absolutely convinced. And so are the major automobile manufacturers, because they're still driving forward with their fuel cell electric vehicle programs.
I can just briefly add to what my colleague said. From the studies we've done, price of batteries today, lithium-ion, is between $500 to $600 per kilowatt hours. We believe if you can reach 50 million cell production, which is roughly about 100,000 vehicles, which is what my colleague said, you can ride on the economies of scale very sharply and bring prices down 50 to 70%. So the magic number there really is how, as you as a cell or a battery manufacturer, can bring in production up to 100,000. And let's remember, the cost of manufacturing battery, the labor cost is less than 10%. So it's not about low-cost manufacturing, but more about high-tech manufacturing. Thank you.
Thanks.
Greg Ballinger. I'm wondering what the load on the society for electricity will do to the cost and competition for electricity in society when you go big.
Again,
any comments?
We've done a number of studies working with utilities to look at the impact of electric vehicles on the grid. And the answer is, if we had 1.3 million cars in 2015, or if we even had 1 million cars, as of now, up to 2020, you do not need extra power plants with the volumes that we are forecasting. Yes, if the market was to double than these forecasts, then you would need additional capacity. What will it do to energy prices? As of now, it's not very clear if energy prices would go up for electric vehicles. Now, there are some utilities, like in Germany, who are putting different prices if you're charging a vehicle. You might even have a scenario whereby, like you have with gasoline, when you fill your petrol up, you can pay a premium and have maybe more high-powered gasoline, and some of us do put it. You might have a system whereby you are paying a little premium for energy price, but the reason you're paying that is the company is then taking that funds and putting in more wind power or solar power. So as of now, I can say that there shouldn't be any impact if the forecasts that are being predicted on power plant capacity, at least not for the next 10 years. And also in terms of pricing, it should fairly remain stable. There might be slight premium pricing, but again, nothing very worrying. Thank you.
Thanks very much. I want to thank all of you for coming, and I want to once again thank all of our speakers for great insight into the industry and the market. And if you have any other questions, they'll be around for a little longer as well. So thanks very much.